How are you, my friend? This video is presenting lecture number 27 of the algebra course. This is about functions, finding the domain and range of such functions. If you need to see the other lectures, please, you can visit the playlist Algebra Course Lectures. Now here we will define what is a function, and we will evaluate some functions. Then we will find the domain by so many examples. Just before we define a function, we need to define a relation in mathematics. Relation is easily set of ordered pairs, or simply set of points. So you have a point, 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 point. If you join them, you can get a straight line, or have parabola, or a circle, or a V. So any graph in general is a relation. There is no conditions, just points. Join them, you get a relation. Now, function here is most important. Function, please be careful, from set A to set B. So in the function, we have to have set A, we call it domain. Set B, we call it the range. I can refer to this diagram here. Function is like a machine. I will explain this more. The input here is the domain, or the x values. So the x values are the input and the domain. The function is inside the machine. Then what we get, output, or f of x, or range. All of these are the same. So the function from set A to set B is a relation, which is a rule, we call it, that assigns to each element in A exactly one element in B. Exactly, every x in A has exactly one element in B. Now the element in the B, we call it image. So when we say set of images here in the yellow, set of images, that's the range. Now it looks simple, and it is simple, but you have to understand the word function, the definition, the domain of a function, the range of a function, the image, input, output. And we will see many, many examples. Let's look at functions by arrow diagrams. Look at this. A first number here, 1 goes to 20, 2 goes to 20, 3 goes to 30, 4 goes to 40. That's a function. Okay? Every element has exactly one image. Now, if you look at the second example here, we see from 2, we have 2 goes to 20, 2 goes to 30. So 2 has 2 images, like 2 pictures, 2 y's, 2 values for the y, for one x, not a function. This one is a relation, not a function. This is a relation at the first one, and it is function. Function notation, how do we write functions? Usually we write y equals f of x. This is the way we read it. Y equals, please, f of x. So x is the input, we mentioned that before. Y is the output. X, the values in the x is the domain, values of the y is the range. We will see that later also. So f of x has an equation like f of x is equal to x minus 3, m of x is equal x cubed, etc. G of x is equal x minus this. So we can have, every function has a name, like every person has a name. Now let's see example 1. We have a function g of x minus x squared plus 4x plus 7. Evaluate, find this. How do we read this? I put it for you here. G of 0, g of minus 2, g of minus 1, g of a plus h. See, I started with very simple example. To find g of 0, I think you know, replace every x in the function here by 0. Put 0 there, 0 there. That's the easiest example. Now, g of minus 2, also put minus 2 there in every x. But you have to be careful here, these questions about the signs, S-I-G-N. Now this one, g of minus 1, we go inside and simplify first. So we replace x by -1, we find this value. Then we replace the new value in the same function again. We can have two functions here, g and f maybe, or something. G of a plus h, that's the x here. This is the x like 0. You see 0 here? This is the same as a plus h. Replace all this x by a plus. If you want to try this, you can try it, and then I will show you the answer directly in one slide. G of 0, directly put 0, you get 7. G of -2, be careful about the signs. -4, you get -5. Okay. Now, g of -2, you put, see there is a minus here, outside, -1 squared, +4, -1 plus 7. When you simplify all this is squared plus 1, -1, -4, so that's 2, g of 2. Now we put 2 again back in the same function, so -2 squared plus 4 times 2 plus 7 is equal to 11. Okay, g of a plus h, I said here important because we will see it in another question. A plus h, all it, we put it in the x. So minus, remember there's a formula here. A plus h will be a squared plus 2ah plus h squared. With the minus outside, we change all the signs. We cannot simplify. If you can simplify, you have to. Let's see example 2. Nice question. Given another function, but this function we call it piecewise. See, the function is divided into 3 parts. One function f, 3x plus 8 if x less than 0, etc. This one, x between 0 and 3. This one, x greater than 3. So when we need to evaluate, we call this evaluate the function values at some numbers here. You have first to check this number here includes or belongs to which interval here, the condition. These are the conditions. So let's say f of 0. I cannot use any one I like. No, I have to check where is 0. 0 less than 0, no. 0 between 0 close than 3, yes. So I go there and put 0, etc. here. F of -2, where is -2? Less than 0, so -2 in the first one. So I put -2 here. 3 times -2 plus. You can continue, please, and find the answer. So, as I said, f of 0 is in the absolute value because 0 between 0 closed to 3 open. So I use that one here. -2 less than 0. So I use this one 3 times -2 plus 8. Square root of 10. Square root of 10 is more than 3, right? So I use it here, x squared. So this, we squared this one here plus 7. So that's 17. And then f of half, where is the half? Half between 0 and 3. So I put 2 there times the half minus 5. Put the numbers in the expression we need, you get 1/7. You can check the numbers, please. Now, another example where we have a function and we need to evaluate like a formula or any expression, actually. You can put any expression you like. But this formula here, f of a plus h minus f of a divided by h cannot be 0. We call it difference quotient. That's the name of it. But in the exam, in the quiz or something, we say find this. So what do we do? Take a plus h, just replace it in the x. Then f of a, take a, replace it in the x. That's f and f. H, just leave it as h. Remember here, a plus h, I said important. Let me go back a little, please, and say where we have important here. You see g, a plus h. I said important, this one. So you replace a plus h, all this in the x, every x. Sometimes we have 2 x's, sometimes we have 3 x's, sometimes we have fractions, square root, radicals, cube root, anything. So just replace in every x a plus h. That's the same idea now in question number 3, example number 3. So I take a plus h, replace it in the function here. So it will be a plus h squared minus 3. See, one time I take it. Then another minus. See, this minus, between them is this minus. See, I left it f of a. See, I did this one separate, just to make sure you understand it. Minus f of a, I left f of a. What is f of a? Just put a in the x again here. See, minus, and then f of a becomes a squared minus 3, separate. See, this is f of a. And we have to expand this by the formula that you know, perfect square trinomial, a squared plus 2ah plus h squared. Now, minus here, you change all the signs. You cancel a squared, you cancel the 3, take a common factor, and then we can easily cancel the h because h cannot be 0. So 2a plus h is the answer. Now, this is really important question number 3. You will see more questions in the exam. Net change. What is a net change? By definition, a net change is the value of a function as the input changes from a to b. So we call it f of b minus f of a. A is less than b, which means b is bigger. So it means how much the function value is changing from a to b. So there is a number a here, there is a number b, a is smaller, b is bigger for sure. So if I say find the net change, f of b minus f of a. Look at this simple example here. The function here, 3 minus x squared. Let's say find the net change from minus 2 to 5. So 5 is the bigger, so that's b. Minus 2 is smaller, that's a. So f of 5 minus f of minus 2. Just be careful about plugging in the numbers. Replace x by 5 there. So 3 minus 5 squared. And then there is a minus in the formula here. See this minus in the formula. F of minus 2. In the bracket, put minus 2 there in the x. 3 minus minus 2 squared. So we put minus 2 there. Simplify all these numbers, you get minus 21. Now, another example about net change. Find the net change in the value of the function between the inputs, minus 4 to 6. When we say the inputs, that means the x value. So a is minus 4 and b is 6. You can check these, please, and then you can pause the video a little and then check the answer next slide if you want to try yourself. So this is a minus 4, and b is 6. So we need f of b minus f of a like this example. Now, the answer is 18 because f of b, you can start with f of a or f of b, but in the formula, you have to write the net change f of b minus f of a. You can start with f of a, no problem, or you can start with f of b. See, each one has a line here. So f of b is f of 6, put 6 in the function, 6 squared minus absolute value, minus 20, you get 10 there. F of a, I put minus 4 in the function. When I simplify all these numbers, you can check it please, it will be minus 8. Now f of b, 10, minus f of a, minus 8. The answer is 18 is the net change. Let's look now at the domain of a function. I have mentioned the domain by simple examples. You can see that please in the algebra course, lecture 13. You can go and check if you like. Now here we'll take more advanced examples. Just to remind you, domain is the set of all real numbers for which the expression is defined. In other words, we can say the domain is the values of the x that have images, or the set of inputs. Any way you say it, the important word is domain. Like this here, we have the domain of this function, that's f of x, 1 over x minus 2. See, what will make the denominator 0 here, which will be undefined 1 over 0, 2. So 2 is not in the domain. See, the domain, all the numbers except the 2. So when somebody asks you what is the domain, you have to say the domain is R, or set of all real numbers except 2. You see what is the domain? It's important to be able to find the domain before you graph a function because it will help you to graph it. So if you have a graph, that means you have many points there. All the x values, the domain. All the y values is the range. Let's see more examples here. Find the domain of the following. See, in A, we have points. And this one, B, we have another points. And C, 1 over x squared minus 9, 1 over x squared plus 25. Okay, so the domain are the values of the x. So minus 2, minus 1, 0, 2, and 4. And here the domain is 5, 4, and 5. That's easy. See, here we have the 5 points here, 5 values. See, 5 points, we have 5 values. Why we have here 3 points and 2 values? This is not a function because 5 has 2 images. So that's a relation, but we can still find the domain of any graph. Now, this third one and the fourth one are important because 1 over x squared minus 9, you need to factor it. That's a quadratic. So what will make the denominator 0 here? 3 minus 3. So we have to take 2 numbers outside the real numbers. So we say the domain is R except 3 or minus 3. Second one here, very tricky. Don't say here all real numbers except 5 and minus 5. That's wrong because there is no factoring here in real numbers. So there is no number in number D. Please, very, very important here. There is no number, you can try yourself, that will make the denominator 0, no number. So we say the domain all real numbers from minus infinity to plus infinity. If you try any number there, 0, 1 minus 1, 5 minus 5, 2 minus 2, 3 minus 3, etc., you will get a value for the function. Let's see more and more. Find the domain of the following. F of x square root of x minus 3, 1 over square root of x minus 10. And here we have square root similar to number 1, but I put squared here. You see x squared minus 3. And I said very important. You will know why after a few minutes. Let's take the first one. See, here we don't have a fraction here in number 1. So to find the domain, we need to make sure that all these numbers under the radical, which we call it radicand, remember? Radicand, and this number we call it index. So it should be positive number here. We cannot accept, like if I put 0 here, see in the x, if I put 0, 0 minus 3, square root of minus 3, that's complex. So we don't accept it in the real numbers. So I will say again, see 1 and 2 in one slide, number 3 is another slide. So when you see radicals here, especially if you see the index even, oh, look carefully here, radicand and the index even. So you take all the radicand here, what is the radicand? X minus 3, all of it, greater than, you have to think of this, must have all this greater than or equal to 0. So when you solve the inequality here, x greater than 3, that's a linear. So the domain is from closed 3 to infinity. That's the domain now. Now in number 2, we have radical down, we have a fraction. See, we cannot accept 0 here in the denominator, but the radicand should be positive. So look at the trick here. So I say radicand greater. I don't put equal. If radical in the denominator here, you put greater. So x minus 10 greater than 0, x greater than 10, the domain from 10 to infinity. Now, can you try number 3, please? So much important. Number 1, x minus 3 under the square root. Here, x squared minus 3 under the square root. Did you finish? Okay, let's try. All right. Now, do you remember lecture 25 I put here? table of signs. You take the radicand, as I mentioned in number 1, x squared minus 3 greater than or equal to 0, then you factor it. X plus square root of 3, x minus square root of 3, then you need table of signs. Table of signs, that means inequalities, polynomial. Please, you can see the algebra course, lecture 25. So that will be x plus square root of 3, x minus square root of 3. You know how to do it. You have to check the lecture if you need to see more examples. Choose any number there. You put all the zeros here on the table, minus square root of 3, square root of 3. Choose a number between minus infinity to minus 3. I can choose very far number like minus 50 or minus 100. So the both will be negative here. If I put it in the x, if I put 0 here between these two numbers, it will be plus and minus. If I take 75 or 100, it will be plus and plus. So when I multiply, I get plus here. Plus and minus, it will be minus. I choose the positive. So from minus infinity to minus square root of 3 closed, union square root of 3 closed to infinity. See, that's not easy answer for number 3. Number 1 was easy because the inequality was linear. Now, that's a little summary of the domain so far. A, B, C, D. I put 4 ideas here. If the function is a rational function, like we call this one here, 1 over x squared minus x, 1 over x minus 2, something rational, then the domain, all real numbers except the zeros of the denominator. So this one you have to factor here, take x out, x minus 1. What will make the denominator 0? 0 and 1. But you have to say all real numbers except 0 and 1. Don't say 0 and 1. That's wrong. You say the domain is R except 0 and 1. Now, if you see radical, square root, or any index here, even, remember, we'll see the odd index in number D here, down. So let's go back to B. Square root of m, fourth root of m, sixth root of m. The domain is the solution of, take m. M is the radicand, greater than or equal to 0. Solve it. See, like this one here. You need to take x cubed minus x squared, all this greater than or equal to 0. See lecture 25. You will get the domain from 1 close to infinity, union 0. Now, if the function is a polynomial like this, without, listen, polynomial, you have seen polynomials there in lecture 9, in the algebra course, lecture 9. Polynomial, there is no radicals, there is no fractions. All the powers here are 0 or positive integers. So the domain is R, all real numbers. No problem. Put any x there, you will get y. Also, if you have a cube root, or the index is odd here. Domain is all real numbers. Now, sometimes, you will see later, maybe in the old exam questions, like 1 over cube root of something. You have to take care of the fraction. So anytime you have a fraction, you have to make sure the denominator cannot be 0. I will say that again. If you have any fraction in any question, the denominator should not be 0. Now, the range of a function, we have mentioned before, the range is the set of all outputs or values of y or set of images. See, there are 3 definitions for one word. We can say range, easy. Values of the y, set of all outputs, or set of images. Just to find the range is not easy, but I will try to explain as much as we can in the examples, and then later we will see more and more examples. Just to remember before we start, f of x always y. Suppose this function here, f of x, I need square root of x minus 7. I need the range. See, the domain is easy. We did similar. Take the radicand here. Now the range, you have to think of the y. This is f of x is the y. Now in the range, you have to think more than the domain. The domain is easier because there are rules. So in the range, put y here. So you can put y. equals square root of x minus 7. We know the square root by itself is either 0 or positive. If you put 7 there in the x, you get 0y. So 0 is there because 7 in the domain, so 0 in the range. And what else? We take positive because square root is positive always. So y is positive and 0. So that's the range will be from 0 close to infinity. Now later, maybe after a few lectures, when you graph this, or you can graph it now if you want, you will see the range, all the values of y from 0 close to infinity. Let's see now 3 examples in example 7, 3 parts, A, B, C. Find the range f of x to x plus 3, f of x is equal to 2, f of x is equal to x squared minus 4. A little advice here, not big advice, little advice. If you have the graph, or you can graph it, so it's easier to find the range. We will see that in lecture 29 coming. We will graph it, or the graph is there. Easier, I will tell you a method to find the range. So now here, what is the first one? Straight line. Now we know this is y power 1, x power 1, straight line. Just imagine straight line, oblique line. That means the domain and the range are R. Now if you look at number 2 here, f of x is equal to 2. Try to think, what is f of x is equal to 2? That means y is equal to 2. What is the graph? I will show you now. What is the graph? It's a horizontal line, you see? See, horizontal line, we have many points on the line here. See all these points? Infinity of points. Different x, but only one y, 2. So the range is 2. See? What are the y values? Y values in this graph is 2. Now, x squared minus 4, we know that's a parabola when you graph it. You take some points, we have seen before. Take some points and graph it, x-intercept, y-intercept, etc. What do you see? We see that the values of the y, it will start from minus 4. We will not go below that. From minus 4, it will go up until infinity. Now, these are the first 4 examples, 3 and 1 before. About the range, we will see more and more as we proceed in the algebra lectures. Let's go back a little, for example, about the domain of a difficult function. And I said very, very, very important, or very V cubed important. Find the domain of this big function. Now the range, you cannot think now of this one because it's so much complicated. Let's look at the domain. Now we take the radicand, remember? Radicand. Now the radicand here, all this is the radicand. X squared plus 3x minus 70 divided by x plus 5. This is what I mentioned here. Let me go back a little, please, in the summary. See, this is capital M. Just remember that. Capital M. Everything, which means the radicand, everything under the radical, we call it capital M. Now here, to find the domain of this big guy, see, radicand greater than or equal now to 0, because the index here is 2. So I take all this, x squared, you see x squared plus 3x minus 70 over x plus 5. I take it all of this, and then I need to factor here x minus 7, x plus 10 over x plus 5. Remember here, this is all these table of signs I mentioned before. It's in lecture 25. So I put the zeros here. What will make this one 0? 7 minus 10 minus 5. Remember, these zeros are not the solutions. These will help us to find the solutions and the domain. Now I put all the brackets here, x minus 7, x plus 10, x plus 5. I take a number here from minus infinity to minus 10. I take another number from minus 10 to minus 5. You have to be careful here. Let me try here one number. If I take minus infinity to minus 10, let me take minus 50. I put it in the x here, minus 50. So that's a minus, minus, and minus. See, anywhere you can go from -5 to 7. There's a 0 there. Put 0 in the x here. Every x you get minus, plus, plus. And now you multiply and divide. 0 minus 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 becomes minus. Minus plus minus becomes plus. Minus plus plus becomes minus. That's the result. So what do I need? Greater than 0. So I take this one here, minus 10 to minus 5, union 7 to infinity. Now, since we have greater than or equal, I have to make everything closed except infinity. But I know when I check here, I cannot replace x by minus 5. So I have to remove all the numbers that will make the denominator 0. So this one here is open. See, that's a little trick here. If you put closed on the minus 5, that's wrong answer. And you have to know that. You have to check, because minus 5 cannot be acceptable in the domain and the solution of the inequality. Now we reach some old exams questions as usual. Every question here we did similar to the in another example, or maybe a little close. So this is a function piecewise, find all this. We have another function, find the difference quotient, simplify it. Find the net change, we have seen similar. Find the domain, this is a question 4, 1, 2, 3. So there are 3 parts here. And I put on purpose here the same expression. See, x squared plus 5x minus 24. One time, 1 over that. One time, 4th root of this. One time without anything. Please try it. Another questions here also. 1 over this in the absolute value. Square root of the absolute value without anything. Please try these in the domain. Number 6, a big domain here, 4th root of all this inside. Please try it. And then another domain, square root of all this. And number 8, find the range of each function here, 1, 2, a, b, c, d, e. There are 5, and then the answers are there. So just be careful here, guys. 8 has 2 lines because there are 5 parts. So this is 8 and 8. It's not 8 and 9, 8 and 8, because A, B, and then C, D, E. 5 answers. And then these only the answers. So for the complete solution, please, on this, you can see the video on all the exams questions, functions, and domains. Thank you for watching. If you like the video, you can subscribe and share it with your friends. Just to remind you, this is lecture 27 about functions. Thank you for listening, guys, and I wish I can see you in another video with another topic. Thank you very much.